Okay, so now we're going to do the problem, the higher dimensional problem of finding a best fit line. So I want you to just pick 4 random points and go ahead and write them in.
And we're just doing this in 2 space?
Yep.
Alright, let's do 0 or 2 0.
And just write them a little better.
Okay. 2 0. How about we do 3 3. 1 4, and then 4 3.
Okay. And we're going to try to find the best fit line through those 4 points. So what does that even mean, the best fit line?
So it's the line that minimizes the error between the 4 points. Like minimizes the distance, so maybe it goes like this.
Okay.
It minimizes the distance between this point and this line.
Alright.
I guess the direct distance, it's going to be like that.
Is that what it minimizes, or does it minimize the vertical distance?
I think it might minimize the vertical distance. I think in the pictures it looks like it's vertical.
Okay.
So.
Alright, so we'll have to understand that and even see if there's a difference.
I mean, it doesn't. You're minimizing as long as you keep what you're minimizing between the points the same. It should be okay.
All right.
So minimizes some distance between the point and the line.
Okay, and what's the procedure going to be here? Like, what are we going to do?
So if I'm remembering right, we're gonna. We have we get 4 linear equations that we have to solve. So I think it was, I forget what they used, but it's like cx plus or c plus dx equals y.
Okay.
So like for this first point, it's going to be c plus.
Which point are you calling the first point?
This 0.14.
Okay.
C plus d times 1 equals 4. And then c plus d times 2 equals 0. C plus d times 3 equals 3. And c plus d times 4 equals 3.
Alright.
So in a perfect world, these would all be on one line, but that is not going to happen.
Okay.
So we have to...
Here, let's not erase. Let's go to the second whiteboard. So what are you going to do?
We have to solve... We get 3 matrices that we need in order to solve this. So we get the matrix A, or matrix A, which has 2 columns. That's the C's and the D's.
A little bit more room.
The C and the D coefficients, and the C goes first. So it's 1, 1, 1, 1. And then 1, 2, 3, 4. The matrix B, which is 4, 0, 3, 3.
Mm-hmm.
And then the matrix X hat, which is CD in this case, and that's what we're solving for.
Okay, and what is your matrix equation that you're trying to solve here?
So I think our equation is A transposed A X hat equals A transpose B.
Even before that equation, what is the equation you're trying to solve?
Right. It's A X hat equals B. That's what our linear equations up here are saying.
Okay, and what's the problem with trying to solve that?
This doesn't have a solution.
Okay, why not in general?
Because to solve a 2-variable equation, or a two equation with 2 unknowns, you need 2 equations. And if you have 4 equations, it's not going to result in a solution.
Okay, most of the time.
Because if you just take any 2 equations, you're going to get different solutions.
Okay, and then what's the idea that we follow here?
So we're multiplying both sides by the transposed, or the transpose of A.
Okay, and why? Why do we do that?
I don't remember exactly why.
Okay.
But this, I think what it does is it makes a, when you multiply by the transpose, into a 2 by 2,
Mm-hmm.
which makes this equation solvable. And then this has to come on the other side because you're multiplying by the transpose
Okay.
on both sides.
Alright, so the reason we're doing this, we'll solve this equation in the next video, but the reason we're doing this is very similar sort of situation. So we're trying to do some projection and find the nearest fit in some sense to this vector in the plane spanned by these two things. So we're doing a projection just like we were doing before, and we get a very similar set of equations. And we'll talk about this a little more. I know this is still like the first time you've been seeing this week. We'll talk about this a little more because it's important to understand where it comes from, but it comes from a picture that's very similar to the one-dimensional case we looked at before. But let's go ahead and solve this now, and in the next video.